Fundamental theorem of integral calculus. The integral of f of x dx is the indefinite integral. It represents the general antiderivative of the function being integrated. And we've done that, okay, and it's general because at the end of each one we've always put the plus c, because we're never certain of what that constant is. That's why it's called the indefinite integral, okay. The fundamental theorem of integral calculus enables areas under graphs to be calculated exactly. Remember, we use the rectangle method, but often that leads to inaccuracies. It applies only when functions are smooth and continuous, okay, over the interval a to b. So smooth, remember, there's no cusps, okay, and continuous means there's no gaps in the function, okay, as there is in a discontinuous function like that. So neither of those situations will work for finding area here. Okay, we need a smooth function and continuous. It's important. Okay, sorry. So the area, as we saw in the last video, is the integral between b and a of f of x dx. To get capital Fx here, the function, we integrate f of x. Okay, and they're what's called our terminals, b and a. Okay, that is the right-hand terminal. That is the left-hand terminal. So when we're finding an area under a graph, okay, looking at that and that, that's our right terminal and that's our left terminal. And we find out this definite integral by putting the right-hand terminal into the function minus putting the left-hand terminal into the function, and that will give us an answer. Okay, here's some properties of indefinite integrals. If both terminals are the same, we get a result of 0. Now, as we saw with our indefinite integrals, if we have a constant there, k f of x, that same k can pop out the front there of the integration sign. If we've got terminals b and a there, if we reverse the terminals, the sign on the definite integral changes. So integral between b and a of f of x dx is the same as negative the integral a to b of f of x dx. Get rid of all those squares so you can see more clearly. Okay, now if you introduce another terminal here like c, the integral of b to a, f of x dx, is the integral of c of a third terminal, of f of x dx, plus integral of b to c, f of x dx, as long as c is in between a and b. And showed you this one before. If you integrate, to get the definite integral of two functions, it's the same as the definite integral of one function plus the definite integral of the other function with the same terminals. Let's do some. Okay, here's our first definite integral. So integral from 3 to 0, 3x squared plus 4x minus 1 dx. Okay, so we're going to integrate 3x squared, so that's going to be 3x cubed on 3, which is x cubed, plus the integral of 4x squared on 2 is going to be 2x squared. Integral of negative 1 is negative x. Close our square brackets, place in our two terminals. Then we place 3 into there for x, so you can see I'm doing that. Square bracket around it, minus putting 0 in there for x. Now it's not easy to see what's going to happen if you put 0 in here, but anyway, we'll still do it. Alright, so then we evaluate, should have my equal signs here. Notice how with the definite integral there's no plus c, because it's a definite integral on this occasion. We're trying to find the definite value by placing 3 and 0 in. Okay, so now we get 27 plus 18 minus 3. Of course, all of that there is going to be 0. So that's going to be my answer. 45 minus 3 is 42. Next one's a little bit trickier. So first of all, before we do anything, we're going to change this to 4 outside of 2x plus 1 to the power of negative 3. We should always do that in that situation. Then we're in a position to get the integral of this between 2 and 1. So we've got 4. We raise the bracket by a power of 1, which is negative 2, over the coefficient of x, which is 2, multiplied by neg 2. So that's going to equal, well, we're going to get here, 2 times neg 2 is neg 4, cancel with the positive 4, 4 and neg 4 cancel. Okay, if we've got 4 on the bottom, on the top, and neg 4 on the bottom, the denominator, that's going to all cancel to be neg 1. Okay, so we get neg 1, 2x plus 1 to the neg 2, square brackets 2 and 1. Should then make that negative 1, actually better write that out better, negative 1 over 2x plus 1 squared. And our terminals 2 and 1. Okay, now we place our terminals in, starting with 2. We'll go with the square. Whoops. Go with the square bracket. Go with the square bracket again. Minus 1 over 2 times 2 plus 1 all squared, minus negative 1 over 2 times 1 plus 1 all squared. Square bracket around that as well. Equals negative 1 over 2 times 2 is 4 plus 1 is 5. 5 squared is 25. Minus neg 1 over 2 ones are 2 plus 1 is 3. 3 squared is 9. Equals negative 1 on 25 plus 1 on 9. Common denominator is 225. So that's going to be, let me see, what's that? Neg 9 on 225 plus 25 on 225. Answer, I'll go up here, equals 16 on 225. Next one, integral between 2 pi and pi of sine x over 6 dx. Okay, so let's get the integral of this. Now, integral of sine expression goes to negative cos, remember, but it's negative 1 over the coefficient of x, which is a 6th here, cosine x over 6 stays the same. And our terminals are 2 pi and pi. Negative 1 over a 6th is going to be negative 6 cos x over 6. Terminals 2 pi and pi. Now we place in our two terminals. First of all, 2 pi. So it's negative 6 cos 2 pi on 6 minus negative 6 cos pi on 6. And we'll copy that over to the next slide. Alright, now from here, it's negative 6 cos 2 pi on 6 is pi on 3, minus negative 6 cos pi on 6. Very neat, sorry. equals, now cos pi on 3 is a half, so minus 6 times a half, minus, and we've got, that's going to be negative 6 times, cos pi on 6 is root 3 on 2. Equals, negative 6 times a half is negative 3, plus 6 root 3 on 2. We can cancel there the 6 and the 2, so we get negative 3 plus 3 root 3, or probably best it's 3 root 3 minus 3. There's our answer. Next example. First of all, we need to integrate. Terminals there and there. Integral of e to the power of 3x, 1 over the coefficient of x, e to the power of 3x, minus 1 over the coefficient of x, e to the negative 3x. Tidy that up, we get 1/3 e to the power of 3x, plus 1/3 e to the power of neg 3x, and then we put our terminals neg 1 and 0. Place in our terminals now, we get 1/3 e to the power of negative 3, 3 times neg 1 is neg 3, plus 1/3 e to the power of 3, neg 3 times neg 1 is positive 3, minus, always subtract, remember, 1/3 e to the power of 3 times 0, plus 1/3 e to the power of negative 3 times 0. Alright, so we've now got 1/3 e to the power of negative 1/3, plus 1/3 e to the power of 3. If I said negative 1/3 just then, I meant negative 3. Minus, this here is going to be e to the power of 0, which is 1, so we're going to get 1/3. This here will also be e to the power of 0, which is 1. Okay, so we're going to get plus 1/3 there as well. So we're going to get 1/3 e to the power of negative 3 plus 1/3 e to the power of 3 minus 2/3. We could, if we wanted to take 1/3 out as a common factor there, e to the power of negative 3 plus e to the power of 3 minus 2. And we're done. Typical exam type question here. If the integral from k to 0 of 8x dx equals 36, find k. Right, so let's find, first of all, the integral of 8x. It'll be 8x squared on 2, which would be 4x squared from k to 0. That's going to be 4. So we're going to put our two terminals in now. So it's going to be 4. So we put in k in for x. K squared minus 4 times 0 squared, by putting 0 in for x. Okay, equals 4k squared. Now we're told, we now have equated two things. We've equated that with that, and we're told that that equals 36. So therefore, logically, it suggests that 4k squared equals 36. K squared equals 9. K equals plus or minus 3. Alrighty, so now you're in a position to do exercise 9E. Away you go.